Multiple mass systems is lesson 3, and there are multiple ways of looking at this type of problem. I'm going to show you one way of looking at it, the way that I have found to be clearest for most people. If you find a different way that you like to think about it, feel free to go with that as long as it works out for you. So we're going to just go straight down to this system of masses here, and we're going to figure out what's the acceleration. First of all, there are going to be multiple parts to this thing. So first of all, we want to figure out the acceleration of the whole thing. So think of it like this. We've got one box that has a rope attached to it right here that's pulling with 40 newtons of force. Okay? But that box is attached by a rope to another box. And so by pulling on the first box, you are actually pulling both boxes. Right? It's not like you're pulling 10 kilograms. If you have two things that are attached to each other, you're actually pulling both of them. Right? So when you're pulling on the first box on M2 over here, you're actually pulling 22 kilograms and not just the 10 kilograms of the first box. And so when we look at F net equals ma, which is what we're going to use to figure out that acceleration, we are looking at, since there's no friction, there's only a pulling force involved here. Okay, we can forget about this middle tension over here, because when we are pulling the front box, the only function of that tension is to hold the two boxes together. So it's unnecessary to even take that into account for the first box, or for finding the acceleration, because that tension is not really involved in the motion to the right. Okay, so F net equals ma, so we just really need to look at that force on mass number 2. I don't know why I called it mass number 2 instead of mass number 1, since it's the first box being pulled, but maybe the whole left to right reading thing. Anyway, we're going to go with it. That's M2. So the force is equal to 22 kilograms times A. And this force, let's just replace that force with the 40 newtons that we know we're pulling with. And so we can figure out the acceleration really quickly and easily. 40 newtons divided by 22 is equal to 1.82 meters per second squared. And that's to the right. Okay, so we've figured out the acceleration of the set of boxes. There's very little to it. The kind of key to figuring out the acceleration is to make sure that you know that you're pulling both boxes at the same time. So you're pulling both masses. So if it were 3 boxes, totally valid, you'd just add up all 3 masses instead of just the first 2. Okay, so that's part number 1. The second part, we're going to calculate the tension in between those 2 boxes, that T for the rope in between. Okay, so let's just look at that second box. So I'm going to redraw this just over here, just so we can remember what we're looking at. Here are our 2 boxes and the force pulling them. So we're looking at this tension in the rope in the middle. So here's where there's multiple ways of looking at it, but I think that the clearest way of looking at it is by looking at the forces that are acting on this box, not by looking at that rope as the subject of this equation problem solving that we're doing, but looking at that box as the subject. Okay, and so that box is experiencing a tension force pulling it to the right. Or it's experiencing a pulling force to the right, and that pulling force is that tension in the rope. Okay, and so when we do F net equals ma for that box, we're going to remember that this box is 12 kilograms. And the only force acting on the box, since there is no friction, there will be friction later on, but when you're doing F net equals ma, then you just need to take into account both the tension and the friction then, right? And not just the tension. So it's not much different. But the tension in that rope is going to be equal to the 12 kilograms this time, not both boxes, because that tension is only pulling on the 12 kilogram box. That's the way we're looking at it anyway. Again, multiple ways to look at it. So if you search around on the internet a little bit, you might find a different perspective, but you will get the same answer from both of them. So that 12 kilograms, and we know its acceleration. We figured that out in part A. Just because we're only looking at the second box now does not mean that suddenly its acceleration is different. It's still being pulled along by the first box. And so that acceleration is 1.82 meters per second squared. And so the tension in the rope then is 21.84 newtons. Not the right sig figs, but let's just go with it. And that's to the right. Okay, so the tension in the rope, let's just look at the one box that it's applied to, and that will make it a lot clearer to figure it out.